Hello and welcome to Unite Los Angeles 2018. We are live here at the Orpheum Theatre here in Los Angeles. Hello, Liz McCurry.
Hi, Will Goldston. And so why are we here?
We are here for Unite LA 2018, and you're in the right place if you've come to watch the keynote.
Oh my goodness. And we have a great keynote lined up for you.
And in that keynote, what are we expecting to see?
Well, for all you visual effects artists out there, we've got a really great reveal coming up for you, so please stay tuned for that.
Exactly. We have a whole bunch of new stuff on the ECS system, so whenever you hear us talk about performance by default, you'll see a bunch of new projects from Joachim and the Game Code team. And also, very excited about this one, the FPS sample game. So if you're looking to make a networked first-person shooter, then you're in the right place. Watch out for this amazing project up in the keynote very shortly.
I'm very excited about that. So, it's been the first day of Unite LA today, and the expo floor's been pretty awesome. So we've got a really great Made with Unity showcase. Mm-hmm. So there's been some great games on there. So Golf Club Wasteland in particular.
I love Golf Club Wasteland.
Oh my gosh, it's amazing.
It's a very atmospheric, kind of like sci-fi, futuristic golf game. It's kind of, I think of it kind of like that Alto's Adventure kind of vibe. It's a mobile game. You should definitely check it out. What else did you see?
Great soundtrack as well. So then there was also Drone. If you tuned into our live show at GDC, we interviewed the drone team for that. And that's coming on fantastic. It looks graphically sweet.
Yeah, I liked Osiris New Dawn as well.
Yes, of course.
That's using the HD render pipeline, which is pretty cool. It looks gorgeous.
Really great to see that.
And of course, not everybody's here, but if you are not here, then you can check out some of these games at madewith.unity.com. And yeah, please do go and play them.
That should be on the bottom of this screen.
Yes, there's the link right there. And what else have you been up to? You've been at the Film and Animation Summit today, right?
Yeah, so for the first time ever at Unite, we've had a Film and Animation Summit. So this is where all of the producers, directors, virtual cinematographers, all of those awesome film peeps can come together and learn more and share their process for creating film and stories in using Unity.
And we have a little treat for people who want to actually get started making films in Unity, right?
Yeah, so really recently we released the Film Sample Project. And so what you can do is you can go to the asset store and download the Film Sample Project. And it's a great template for getting started with if you're wanting to create your cinematic shorts or films. And it's actually informed by the processes used by like Disney with their Baymax streams.
Yeah, and of course Adam 2
and 3 Adam 2
Oats.
by Oats Studios. Yep. So please do pop along to the asset store, download that. There's also an accompanying blog to get you started with. So go make your cinematic masterpieces.
Absolutely. And the keynote begins in just a while, so if you've just joined us, welcome. You're in the right place for the keynote. And in the keynote, you'll also see some things from film industry veterans talking about their use of Unity as well.
Very excited to see that.
And obviously, we're here streaming the keynote, but we're not just streaming the keynote from this event, we're also streaming a whole bunch of different sessions as well.
Yes, we are. So what do we have today?
I was going to ask you that.
Ask me.
Okay, I'll tell you. Well, today we had a bunch of sessions on the new prefab system and also the lightweight render pipeline. And in those sessions, you got to learn about how to use all of that stuff. If you didn't see them live today, you can catch them on our YouTube channel later. And tomorrow, what have we got tomorrow? Oh, ECS tomorrow, right?
Oh my gosh, so we have a full day dedicated to ECS tomorrow. So we have 9 sessions being covered by our CTO, Joachim, and that's going to cover the whole performance by default. So we're going to be looking at the ECS API, but also the Burst compiler too. Yep. So it's super exciting, whole full day track.
Exactly. So there's a whole bunch of different sessions on that, and we'll be doing the same thing for every day of the event. Speaking of ECS, Elizabeth, we have a very special guest about ECS. So let's go meet him right now.
Yeah.
Where is Garth? Where is Garth?
There he is.
Do we have a Garth? There he is.
So this is Garth.
He showed up just in time. I can't believe it.
He is the lead programmer of TikTok Games. Hi, Garth. So tell us more about TikTok Games and what you do.
So I'm a lead programmer at TikTok Games. We're a game studio in Burbank, California. We have about 40 employees, 5 programmers. And I was here giving a talk on Unity ECS earlier today. So it's something we've been doing.
So how come you guys are quite really early adopters, right? You've been picking this up. What actually led you to jump on top of ECS so quickly?
So actually, we've been looking at using ECS before as a software design pattern. We really like it. It keeps our data-oriented programming working really well. So we had actually already been using ECS, a homeworld one, and then we saw that Unity was coming out with their own ECS system. So we decided we'd give it a try, and everyone in the studio has been trying it out, and we've been learning it together. So it's been a lot of fun.
And so what are the benefits that you've seen from implementing ECS?
Well, the number one reason for ECS, of course, is performance. That's what we all want. So that was definitely a part of it. There's performance by default is something I've heard Unity say a lot of times. And I think if you really understand how ECS works and how to program, then you can get that performance by default. And it's a huge performance gain, too. So once you get the hang of it. That's definitely number one reason. The other reason is because humans can understand it. And yeah, it's been fun to learn.
So where can people find, so they can't find your game just yet with ECS, or?
So right now, with ECS, our current games are under NDA. So I can't say, it is brand new library, so we haven't had a chance to publish it yet. But we do have Smurfs Bubble Stories, the last game we published, and that is available right now on Google and Android and iOS.
And if people want to follow all of your other projects, what's your website? Where do you want people to look?
TikTokgames.com. We're also on Twitter and Facebook and all that stuff. So.
And that's TICTOC, right?
TICTOC. Yeah, TikTok Games.
Grant, thank you so much, man. Yeah, and you best go and get a seat. Much. We'll see you shortly.
Enjoy the rest of the keynote.
Thanks, man.
Thank you.
Cool. So we also took a bunch of questions from you in the community the past few days. We had a bunch come in via Twitter, so thank you.
Thank you, everybody. That was awesome.
So what do we get, Liz? I got a bunch of them here.
Yeah, we had some really great questions, so thank you. So one that we did get was from Anjin Games, so thank you. And he said, or she said, are there any plans to have a full modeling toolkit for like extrusion and beveling, etc.? Okay, Anjin, I think what may be super useful for you is Pro Builder. So you can go to the package manager in Unity, download Pro Builder, get started straight away. And this is a way for you to create, but also edit meshes in the Unity editor. So please go to package manager and download that. Yeah,
so if you didn't think that Pro Builder was the right thing for you, then definitely go and check it out. We're adding new features to it all the time. 4.0 of Pro Builder just came out, for example, and you can get that, like Liz said, via the package manager. We had another question from Jason Terry who asked, he said that Joachim, our CTO, had mentioned background asset importing some time ago, and what's happened with that? Mm-hmm. So the answer to that is it's part of the new asset import database, and you'll see that released throughout 2019. And basically the idea is that we're overhauling the asset database, and in 2019 2 and 3 what we're working towards is import on demand. So you're going to open up a project, everything will just be there ready for you, and as soon as you open a scene it'll import all of those dependencies ready for you. So it's super cool.
That sounds great.
And then as usual, anytime we post anything on Twitter or Facebook or YouTube, the first thing anyone says is, that's great, I love feature X, but what about the terrain system, guys? Where's the terrain system? It's always the thing that you haven't done. And granted, they're not wrong. You're not wrong. We haven't done much with the terrain system for way too long. So in 2018.3, we have quite a treat for you guys. We've got everything moved over to the GPU except for a few short things. That's about 30x speed improvements. We've got all new tools, got new UX, the stamp
multi-terrain support.
Multi-terrain support.
Yep. You can create your own brushes.
We hope that basically it's everything that you've been asking for the past decade. So we're hoping that that's really popular. Speaking of 18.3.
Yes.
The beta is out, and we do want your feedback. So we need that as soon as you can. Go and try it out. Tell us what you think of the new features. Pull in the packages that are compatible with that and try those out as well.
And I guess that's something to mention with 2018.3 in the Unity Hub, right?
Yes, absolutely. So if you're looking to get 2018.3, do download the Unity Hub. That's going to be the new way of getting hold of Unity installs and features as of 2019.1. There's not going to be a launcher anymore. You're going to use the Hub all the time. So go and check it out right now.
And thank you to everybody who's taken part in the beta so far. We really appreciate it.
Yeah, it's so good. We really appreciate all your help, and we couldn't release a new version of Unity without that.
So for those of you that are just joining us, we're here for the Unite LA keynote at this beautiful location, the Orpheum Theatre.
It is pretty cool, I have to say. It's a very sort of cool old Art Deco building, and you know, it kind of, some of you may recognize it from the video game BioShock. I think it was actually the set of BioShock, right?
I hope there's not a New Year's Ball about
There's
to start.
no New Year's Ball, don't worry about it.
Oh.
And our program will be starting in 10 minutes. There's the 10-minute warning. So basically what's happened here is we forgot to switch off that monitor. So we're just going to listen to Bill for a while talking about our program starting in 10 minutes.
10 minutes if you didn't catch
Yeah, so it is 10 minutes. And welcome if you've just joined us. We are counting down 10 minutes to the keynote. And in the keynote, you're going to see a bunch of cool things. Like we mentioned, you're going to see updates about film and animation, some stuff on our new networking code, some stuff on HD render pipeline, and a very exciting new opportunity for Cinemachine and some other stuff that I nearly spoiled just then. And then I've just pulled back from spoiling that stuff too badly.
So we were recently just talking about the 2018.3 beta. If you'd like to actually give more direct feedback to us, we've actually launched a new initiative called the Advisory Panel. So you can pop along to the link that will be at the bottom of this screen.
We hope,
and be part of the advisory panel. And so what this is it's a way for, informed by your interests, for us to invite you to, interest groups or panels to test new features and give us feedback directly.
Absolutely.
Yeah, and in return for that, we'll give you some Unity goodies. We've got discounts and gift cards, and we'll even donate to charity for you. So please do get involved if you want to be part of that direct feedback. We would really value it.
Speaking of feedback and community members, I think we have another special guest, don't we, Liz?
Yes, we have. This is the lovely
Angela.
Angela, the creative director
Angela
of
Haddad,
One Third
welcome.
Blue.
Thank you so much. How are you guys?
Very good, thanks. So Angela, tell us about One Third Blue and what you do.
So One Third Blue is my VR AR art content development studio. I work with brands to create exciting, impactful brand and marketing experiences for their audiences.
And we cheated a little bit. We had a little look at your Instagram before we got on here because we know what your work's like. And I checked it out and I noticed you've got this very cool watercolor style. How do you get from watercolor on a canvas over to a Unity project? Tell me about that.
Awesome, yeah. So the process of my work really varies from project to project, but specifically with what you're talking about, I really paint watercolor on paper, on canvas. I scan it in, I digitally retouch it, and then I bring it into something like a Unity if it's a room scale interactive experience, or something like an After Effects if it's a 360 flat video, and then I create animation from there to create these 360 immersive environments.
And so are you working for client projects, like installations? What kind of projects are you doing and who are you doing them for?
Awesome. So I work with brands like Live Nation, Marie Claire, Al Jazeera to create these experiences for their audiences. And sometimes it is live installations for them to bring these first-hand experiences to their fans and audiences. Other times it is a 360 video that gets published on a desktop or a web for people to watch them online in a more accessible way.
Liz.
And so what advice would you give to people who are maybe wanting to start out in virtual reality or VR art?
Yeah, so with VR art specifically, I really would say that you have to get your hands dirty. You have to get access to the tools, something like Tilt Brush or Quill or Google Blocks, and then import them into something like a Unity where you can really develop your workflow in an effective way. So that's something that's really important. And of course, what's really critical is getting to know people, researching what you want to do, seeing what people out there are doing so that you can really refine your craft in a higher potential.
That's amazing. And we also saw when we stalked your Instagram that you've worked for a number of really cool clients. Could you tell us a little bit more about the projects and maybe how you find those clients?
Yeah, so a huge bulk of my projects have been incoming inquiries, but I will say that it is very critical to kind of develop a steady business development method. I think that that's what's going to make you sustainable, whether you're a freelancer or a development studio. So if you can really hone in on how do I keep my business development skills, perfected, and how do I hone in on a method that's going to work for me every single time. And it is more difficult that way. It's not going to, it's not a guaranteed method, but what I would say is you really want to also supplement that with getting to know people and networking and, putting your work out there and seeing what other people are doing and, offering help to them, and hopefully they can offer you help. So things like that are really critical, I think.
And so where can we find more about your art?
Awesome. So I'm very active on Instagram. I publish work almost every day at One Third Blue on Instagram.
Awesome. Cool. Thank you so much for coming on, Angela.
Thank you so much. Please enjoy the keynote.
Yeah. Cool. See you soon.
Thank you so much.
Awesome. So
That's
if you
incredible.
have just joined us, we are 5 minutes away from the Unite 2018 keynote. Can you believe it?
Oh my goodness, I can't wait. So if you've just tuned in, we've got some great keynote loveliness for you. So for you visual effects artists out there, please stay tuned. We have something for you. If you're all about performance, we've got some little ECS treats.
There's loads. We've got the networking project. We've got all kinds of things coming up. The thing is, we're not really allowed to tell you what's in the keynote.
But we really want to.
We really want to. And it's not that we don't know what's in it. We know what's in it. Liz knows what's in it. I know what's in it. But we can't tell you just yet. So I'm going to move swiftly on. What you'll also see in the keynote is the Universal Game Dev Challenge.
Goodness.
And there's just a little note from Bill. It's going to be starting in 5 minutes.
Thanks,
I'm going to let Bill finish and hope that someone switches off that monitor really soon. So we're going to have a little look inside the building right now. So you can see that the room is filling up.
Yeah, and there's
loads of people here. There's a few latecomers just kind of straggling in. You're all late.
They're okay. They're all cool.
It's 5 minutes, guys. So 4 minutes.
4 minutes.
4 minutes. So things are heating up here. And so yeah, we have the Universal Game Dev Challenge. Exactly.
So some of you may remember that we launched this at GDC, and it was a partnership with Universal that gave the Unity community access to 5 great, awesome IPs.
And what were they?
Jaws, Turok, Back to the Future, Battlestar Galactica, Voltron.
Correct.
Did it.
Nailed it.
And we're going to be finding out more about the winners of that in the keynote, so please stay tuned.
Absolutely. And recently we did a Unity Humble Bundle, and we wanted to thank everybody who took part in the Humble Bundle, purchased it. Some great games in there. Oxenfree was in there.
Oxenfree was in there, and also some great Unity assets like Gaia. So it was a really cool kind of like merge of, hey, I want to play games, but I also want to create them.
Yeah.
So
and
yeah,
also, most importantly, we made. How much did we make? $380,000 for which charity?
Girls Who Code.
Girls Who Code.
So thank you very much.
Thank you for that.
To everybody
cool
who got involved with that. It's
Absolutely.
amazing.
And the Unity Awards are coming up in December.
Yeah, they are. So the online Unity Awards are back, and voting begins on December the 1st. If there's a game or project that you want to submit, please, please, please tweet about it with the hashtag Unity Awards.
Hashtag Unity Awards, indeed. So if there's anything, it's kind of amazing. Like we did the first one of these in 2008, and we watched some of the trailers the other day, like to compare, and it's absolutely insane what all of you have been creating in the past decade. It's absolutely crazy.
Incredible.
It makes me feel really old, so thank you for that. But two, it's just super cool, like how far the tech's come and how far the games have come as well.
So please tweet about the projects and games that you'd like to nominate with the hashtag Unity Awards. We want to hear from you.
So we are just 2 minutes away from the Unite Los Angeles 2018 keynote. We've got a lot of people, all of your favorites are there. Lucas is there, Adam Myhill's there. They're here to tell us about all of those new features that are coming up. And I don't think we can tease many more of them at this point. But
I'm pretty excited about the
what are you excited about?
FPS sample game because it looks amazing.
It does.
And I've seen like people play it, like set up on the stands at the showcase on the expo floor.
Yeah, you can play it at the showcase as well. It's pretty cool.
It's good to see the like devs who created it getting a bit competitive with each other.
So the thing that's actually really cool about this is that, well, you'll see.
Yeah.
I think we spoiled even more of this project. You're going to see in about 2 minutes' time, maybe even 1 minute's time, what's cool about this project, because we're going to show you absolutely everything that's going on. And it's nearly time.
Oh my goodness!
Hello.
The popcorn means that it's time.
It is time to go.
Keynote. Let's do this.
It's not quite time because I need some popcorn.
Why give me popcorn if it's not time?
Because we're counting down. It's nearly time.
Oh, I can hear the countdown.
We're in a holding pattern.
We are 1 minute away from the keynote.
I'm pretty excited.
So let's have some little reminders of what we've got coming up for you.
Yep.
So for you VFX artists, stay tuned for some fancy things that we've got for you.
Brand new tool. Absolutely huge brand new tool, and the demo is awesome.
Yeah, we love a fancy demo, right? And for those of you who love a little bit of performance by default, we have some great ECS treats.
Yeah, you may have heard us mention that.
Very, very shortly. So we've got 30 seconds until the keynote. I can't wait.
Yeah.
It's going to be great.
We need you to interact with us. It's great that you're all here on the live stream. We want to talk to you. Our community team is going to be on the live stream throughout the whole night, and we're going to talk to you after as well, probably very excited and full of popcorn.
Yeah.
And
why give me this and then not let me eat it and watch the keynote? That's just cruel.
I haven't even got a free hand. I'm enjoying it already. So grab yourself some popcorn, get yourself some coffee, some tea, get comfy, strap in, and we're ready for the keynote. Let's do it. Have fun.
Let's go. Enjoy the show. Oh,
excuse me.
Excuse me, please.
Don't sit there.
Oh my gosh, the buzzer here is amazing. Fantastic.
Okay.
Amazing. I can't wait. This is
Look at
going to
these
be great.
people.
Like popcorn.
It's thousands of people. I would love some popcorn, Liz. Thank you very much.
Look at the buzz in here is crazy.
Okay, let's do this. It's keynote time.
Any sufficiently advanced technology is indistinguishable from magic.
I was 11, 12 years old. My dad came home with a computer. It's an MSX machine.
TRS-80.
Commodore 64.
I was really young.
It didn't have a hard drive.
And then it kind of accelerated from there.
If you have to worry about nothing else than what you're actually focusing on, what you're actually passionate about, then there is no way you are not going to succeed.
There's a moment where an experience becomes so intuitive that you don't even think about, the underlying complexities.
What developers can look forward to is the unlimited possibilities that they can create in their own minds.
But to create, you need tools.
We provide you with the tools to do it, and then we kind of step back and just allow you to be the one who's holding the brush or creating the thing that you're envisioning.
I don't think it's in our nature as human beings to just accept things as being good enough.
We're designing an engine to be used by any type of artist with any goal in mind.
The easier we make it for them to express themselves, the more we'll see people who attempt.
We're really at the infancy of what Unity can bring to the world.
I could use it for training pilots.
My son is 11 years old. He's using Unity.
Recreate brain images before they go in and do brain surgery on patients.
We're good for anybody that wants to create.
Gaming is in our DNA. We'll never leave gaming behind.
We'll always be there for you.
I would love to tell everybody who uses Unity, thank you.
Thank you.
Thank you.
Thank you.
Thank you so much.
Thank you.
It's all about the users.
We can hear them like we can hear our family.
Ladies and gentlemen, please welcome John Riccitiello.
So, good evening, and welcome to Unite 2018 in Los Angeles. Tonight, we're going to share with you a bunch of breakthrough technologies. And the bulk of our presentation is going to be focused on games. We're also going to talk about a few other industries. But I'd like to start with a bit about Unity, who we are and what motivates us. We start with a fairly fundamental belief that the world is a better place with more creators in it. Now, we know just how hard it is to be a creator. And we want our developers in a very competitive world to be advantaged. And we're here to help you succeed. We also know how hard it is to translate your imagination to reality, a game or some other technology that you're proud of, for you to find an audience, for you to get a return on what you're looking for, whether that return is measured in dollars and cents, or just the pride of knowing you created something that matters, something that's great. Now, I say creation is hard because it's always hard, but also because some of the biggest companies in the world, the mega behemoth technology companies, are working to sell their own hardware first. And the content you create in that world can be a commodity. In this world, we stand firmly with our developers. We are on your side. Our mission simply is this. We start with this notion that the world's a better place with more creators. We're here to empower you, Unity's creators, with the most accessible and powerful real-time 3D engine and monetization platform. We're here to enable you to succeed in a harsh world. Since we were founded, we've always tried to build technology to serve developers. We listened to our developers and often focused on improving the performance of our engine, trying to get better than we were when you asked. Sometimes we focused on creating a feature or hitting a performance bar that ensured we were better than our competition. And we've been doing this for a decade and a half. And just in the last 5 years, our core engine technology team has gone from less than 100 to over 600, and we stand today with over 1,000 engineers and product people building technology for you to use. We're creating technologies that are not just better or better than competition, but as performant as possible, subject only to the laws of physics. We now seek to push the edge of what is possible. This is, in a word, a revolution. Now, when and how are we doing this? Part of it's next level rendering, our focus on allowing you to build gorgeous, realistic graphics enabled by the new scriptable render pipelines. The new C# job system, which will allow you to write parallel code optimally for multi-core processors. ECS, the entity component system, a new data-centric model for writing high-performance code. And the Burst compiler, which produces highly optimized native code. And later, we're going to show you a demo that even to me is absolutely ridiculous, showing off what you can do using these technologies. And there's more. We're rapidly transforming our ad business to an AI and machine learning driven monetization platform to help you optimize not only how happy your players are in the products you build, but how well they monetize, their LTV, their engagement. You're basically optimizing your business using the huge reach and investment we've made in AI. Now, all of these benefits are here for the game developer, and we like to push the boundaries of technology, but some of this can seem scary. And while we're invested to pushing the boundaries of what's possible, we also have a core understanding that it's absolutely critical that we leave no developer behind. This means we're dedicated to ensuring Unity developers does not have to embrace each of these new technologies as we create them. You can ramp up on your own speed, or not at all, or in steps, or as you're ready. So that's us, investing to enable you to stand out in the world of more creators, investing in leading edge tech limited only by physical constraints and physical laws. And we're here to ensure that none of you, no developers left behind as we push these boundaries forward. We want to be your engineering department. And if you're an engineer, we want to be the team that stands behind you as you set out to do the hardest thing there is to do, create original works of art and technology. Now, we're invested very heavily in games, and will continue to be. But we focus on games because we love them. We love games. I love games. And we love game developers. And frankly, because gaming really is the most challenging of real-time 3D arts, where devs often seek to create highly complex experiences with thousands of 3D objects in a single scene at high resolution. And then they want to show it off at 30, 60, or 120 frames per second. That is a bewilderingly complex task. We're here for you, the game developer, to help you with these and other very challenging goals. But an interesting thing has happened as we built these powerful technologies and kept innovating with our engine. An opportunity to fuel new types of creator dreams in industries like automotive and film, architecture and engineering, construction and more. Our game engine, our little game engine, is now used in all of these industries and is growing rapidly in each. So you might ask, how does this work on other industries cause us to change focus in the game industry? Well, first, these added customers actually enable us to invest even more in our engine. That 600 or the 1,000 engineers that I talked to you about are available to us because we're investing in other industries. And in some places, we're able to invest and grow because there's a new technology that is interesting only in the future of gaming, but is in the present interesting to other industries. A great example of this is auto and film and ray tracing. You've all heard about ray tracing. It's the next big thing. But it's not presently useful in the game industry. Realistically, ray tracing will be interesting in gaming in a few years, maybe 3 to 5 years. But Unity is investing now for film and auto. When we need ray tracing for gaming, we'll be ready with a polished and proven technology. So that's who we are, believers in more creators. We're on your side to ensure you're successful in a competitive world, pushing the boundary of what's possible. We're here to tell you we will make sure that no developer is left behind as we push the envelope. And we're investing in games and other industries to ensure we have the best of all possible technologies for you, our developers. Thank you very much.
Please welcome Timony West.
Hi, everybody. Good evening. Since the introduction of Unity 1.0, we have had the honor of co-developing alongside you. And if we know anything to be true, it is that doing anything worthwhile is hard, especially the art of making games. And as we've grown our development team over the last few years, we have come to realize that making the tools to make the games is also really hard. Go figure, right? So tonight, we have some of the best and brightest minds at Unity coming on stage to talk about the new tech that we are working on to help you solve these hard problems. Okay, but we only have 90 minutes. That's not a lot of time. That is not enough time to talk about all the cool things that we're working on at Unity. So before we go through the schedule, let's talk a little bit about the smaller things. Let's take a look at the small things that we're working on that are making a big impact.
1, 2, 3, listen.
That's a lot of stuff. Addressables. I'm excited for addressables. All right, so let's talk about what we're going to talk about tonight, Tonight, Peter and Brandy are going to come on stage, and they're going to talk about connected games. Peter has a new project that uses netcode and HD render pipeline, and then Brandy is going to go over the connected game roadmap. And then we're going to have Adam Myhill come to the stage and give an update on what's going on with Cinemachine. Arissa and Chad are going to walk through our VFX graph, which gives you more power to make really beautiful industry-grade effects. And then we're going to switch gears, and we're going to talk about how Unity is being used for film. We're going to have Natalie on stage, and Lucas and Mark, and their friends at Disney TV Animation to talk about how they made Baymax streams using Unity. I'm very excited for this one. All right, and then we're going to have Joachim and Martin come to the stage and demonstrate what they mean when we say performance by default. How they and the core R&D team are rebuilding our engine from the foundations to make it easier for you to make beautiful, performant, and massive games in Unity. Okay? So that is the schedule for tonight. But before we get started, let's talk about one of my favorite things, augmented reality, and how it is gaining widespread adoption across various industries. We're going to talk to two different companies that are using augmented reality to explore how games and entertainment are being used to make ordinary, everyday experiences a lot more fun. So please welcome to the stage Ethan Eiler, the director of Ride Experience at Lyft, and Rick Davis, GM at Rewind.
Hey, everybody. Hi. Thanks. Yeah.
Thank you.
So for Lyft, the rider journey is really paramount, and we're always looking for creative and exciting ways, to bring surprise into light to our passengers. In the past, these experiences have ranged from anywhere from fabricating literally dozens of, replica Ghostbusters cars and putting them out onto the platform for people to ride in, to partnering with Netflix and Stranger Things to fabricate Demogorgon haunted house, terror mansions on wheels to scare our passengers.
Nice.
Yeah, that was a fun one. Increasingly, we're living in a world where someone or something is doing the driving for you. And this really unlocks a huge, huge opportunity for in-ride entertainment. And now, the question we're really chasing down is, how do we scale these experiences? So not just the lucky ones who get to ride in the Demogorgon car to get to have the fun, but how do we really make sure that every rider and every ride gets a taste of the magic? We're really, really inspired by all the amazing work everybody in the audience here does on a daily basis in XR and in gaming. And so last year, we partnered with Rewind to kick off an R&D program to just start experimenting with AR and VR and immersive in-car entertainment.
Yeah, and Rewind is one of the best in the business when it comes to making cutting-edge XR experiences. So how did you guys decide to approach this problem?
Yeah, it presented a hard challenge. How do we get hardware that was designed for the static ground to work in the back of a moving car? Our goal was to design an AR platform that any IP could reach millions of users in the press of the button. Now, this wasn't just a standard sort of build experience, press play type project. Instead, we had some ideas, some theories, and a little bit of duct tape, so we got to work testing both AR and VR. It actually looked a little bit like this. A lot of duct tape.
We were very calm about this.
We're getting this for our office, actually, as well. All right, OK, so this looks really fun, but let's get a little bit into the tech. So I'm sure that most of you have probably played with an AR face mask when you're in the back of your Lyft, but that doesn't require the location information. It works pretty seamlessly. It doesn't matter how fast you are going. But traditionally, for more robust spatial experiences, you're going to want to rely on the IMU. But you couldn't do that in this case, so how did you approach the problem?
Yeah, that's right. So if you rely on the IMU in a moving car, your characters fly off into outer space. But we found that with some smart camera tech, as well as the GPS in the car, we're actually able to ensure that the IMU wasn't needed at all. So the end result was that we were able to keep your character fixed to the environment. So the theory here is that if the device knows where it is relative to the car, and the car knows where it is relative to the world, your experience should be able to play out as intended. The flexibility of Unity actually made it really easy to make this work cross-device.
OK, so what was the final tech stack that you ended up with?
Sure. So it was a bit of a combination, but obviously the power of Unity, some internal scripts that we wrote ourselves, as well as ARKit, ARCore, and Vuforia. And the end result was something working on super simple devices like your iPad or your iPhone.
Nice.
So once we had the characters sort of locked to this world, we got together with our creative team and the amazing team at Lyft, as well as legendary creator Bay Rate of games fame, to create a character and a story that the Lyft rider would absolutely love.
Right. And that's how you came up with this guy.
This little guy.
Right.
Yeah, a magical, whimsical tour guide. Now, what we did in this first test was we actually built a brand new kind of stage in the back of a car, one where this digital tour guide is actually controlling the physical lights in the experience, reacting to user behavior, and it's all controlled by a dedicated iPad that's in the hands of every rider.
I really love this. I love seeing this combination of industries, and we're all working towards the same future together. This is awesome.
A lot of fun.
Yeah, these are the projects that we live for at Rewind, and it was such an honor to work with such an innovative brand like Lyft.
So we're really excited to give you guys a sneak peek into some of the AR technology that came out of the work that we did together. So enjoy.
Thanks.
Thank you.
Please welcome Adam Myhill.
Hi, everybody. Okay, we're going to do something that's a little bit crazy. We're going to show you some in-development tech in a game called GTFO, which is still in beta. And we're going to do it right here, which is something you shouldn't normally do, like undone tech. And this tech is called Cinecast. And what it allows you to do is it allows you to direct game content in real time. Okay, so let me back up. What do I mean by that? We've been thinking about this problem for a long time. Cinemachine solves the problem of how you cinematically have a relationship between the subject and the camera. And we figured that out. But the next step is like not a synthetic camera operator, but how do you do a synthetic director? So we're going to put all this tech together, and we're going to show it to you live, and we're going to do it right here, and we're going to bring someone to help us with this. So I'd like to introduce 5-time world champion, Counter-Strike, Stephanie Harvey.
Exciting. Hi.
Hi, Stephanie.
Thank you, Adam. All right, so here's what we're going to do. We're going to play a game of GTFO, and I'm going to cast it live using Cinecast. We're going to first of all meet our players backstage. So let's meet our 4 players. All right, so we have Svante, Mike, Simon, and Ashley. You guys ready, Ashley, and all? Yeah?
Okay, so let me recap what's going to happen. These guys are going to play live backstage. Stephanie's going to be driving Cinecast, switching cameras, and we're going to stream this all live right now. Are you ready?
I mean, I'm ready. It's not my tech.
What could go wrong? Let's do this.
All right, so to give you a little bit more context, we're playing GTFO, a 4-player co-op horror shooter where communication is key to survive. You're a prisoner, and you're forced into a dangerous underground complex, trying to find artifacts to keep your captors satisfied. Okay, so we just got dropped off into this underground complex. As you can see, we have our 4 players here, and they are exploring their map. They have no idea where the enemies are at the moment, but they all have 4 specific tools that can help achieve that objective. Their current objective is to find Zone 11, and we have different tools in this game to do a little bit of co-op. Ashley, for example, has a lot of trip mines. Mike has a glue gun. Simon has a turret. but let's focus on Svante, because he seemed to be our leader at the moment. He's moving forward. Okay, so Svante just found a code, and he's giving it to Simon. Okay, so this just happened. It allows us to see the next objective. They use a co-op mechanic to enter the next objective, which is here on the map. So Svante just used his mapping device. It allows us to see in the next room if there is enemies. This was super important because they switch weapon from shooters to melee weapons to be able to go stealth. They're currently staying in that door in the bioscan because it allows them to open that security door. There's a lot of co-ops mechanic like that in the game. But I think we just found our first enemy here as Simon and Mike took our first enemy really quietly. Svante just took out another one. They're trying to make sure they don't alarm anyone right now. Mike is in a lot of fogs. Simon and Ashley were able to finish the last enemy. Okay, so this room was relatively easy. Svante is scanning one more time the next room. That's all the blue stuff, as you can see. Oh, we have a scout, guys. Okay, this is the most dangerous enemy in GTFO. If you don't kill it right away, it's actually going to call out for a bunch of enemies, and they were not able to kill it. Okay, guys, this is going to become super hectic. Every player needs to use their tools really efficiently. You can see Ashley is currently putting down some trip mines, as Simon also seems to be putting his turret. We have our first strip mine that exploded. Mike used a glue gun to slow down the enemy. Seems to me like they're in control. Our 4 players are fighting forward. A lot of enemies have been called. This was from their mistake because they let the scout call the alarm. We have 2 players that go down simultaneously at the same time. Can't even speak anymore. Ashley moves forward. She should go back and revive her teammate. Ashley, don't go down. We have 1 teammate alive, Simon. Is he going down, guys? I think he just went down, yes. The mission has been failed, guys.
Stephanie. That was so cool. Okay, so before we get into that, we have to thank the GTFO team. Can you believe 9 people made this game, and it was the first game that they made with Unity. So congrats to GTFO. That's amazing. Okay, Stephanie, what was happening?
Okay, so Cinecast allowed me to direct this story all by myself. It was like having a film production crew inside the game working for me to get the best shots. I went fully automatic a couple of times, but I was always also able to focus on specific shots that I wanted.
Right, and it's taken us years to get this technology together to answer the question, like, how do you film something when you don't know what's going to happen next? So let me explain and show you a little bit of the guts of how it works. So this is a gray box scene that we have, and these 4 very finely dressed men run around the level like idiots. And the red cameras, there's 2 layers in the world. So there's ones that are on the wall, and then there's these ones that follow the players around. And the blue lines are raycasts. So each camera is checking to see who it can see. And if a camera can see something, then it's valid. So if you look at the left of the screen, you can see the cameras, the visibility coming on and off. And then when a camera is visible, we move it to the right side, and this is where we do a shot evaluation, and we give a score, like how good is this shot for this given time? And then when it gets really interesting is up top. This is the story manager, and this is what's interesting, like, is a person doing something interesting? Is something in the level interesting? And what Cinecast does is it picks the best camera transition to fulfill what the most interesting thing is happening in the game. You get to configure all this, but this is how we set this up. So when we move to GTFO, look at this example here. And can you believe we had 800 cameras going at once? And we Java-fied all the raycasts, so we didn't even feel the price of that. So it's going to switch over to GTFO. Now, here's a door. Cameras are cutting automatically. But as soon as it opens, we see more enemies. So that's more interesting. So we cut to a wider shot to get all that stuff in. And all of these edits are happening dynamically. That's a little foreshadowing of the player because he's a high importance player. So we cut to him so we can see him ahead of time. So, and like, let's remind ourselves, right? This is what esports looks like right now. It's great, but the cameras can get a little erratic. And isn't it nice to have some other points of view? So that's why we built this thing. So Steph, show us how you drive it.
All right. It was really simple. I was able to pick a close-up, like this on Simon, a wide shot. I was able to do the cuts whenever I wanted. And I was able to go fully automatic with my hands up.
Do a telephoto shot.
Telephoto shot.
Do a wide shot.
Wide shot.
Telephoto shot.
Telephoto shot.
Wide shot.
Wide shot. Faster, faster.
Do the roaming guy. So something else that we do here, and this is a magical part about it, is we delay everything to Cinecast by 3 seconds, but we don't delay it to Cinemachine. And what that means is the cameras can see into the future by 3 seconds, so they can cut and show things just before they happen.
That's right. I didn't have to predict or chase the action. I picked the subject and the type of shot I wanted, and Cinecast figured out the best camera for me.
Yeah, and that delay is a huge part of getting shots. Good quality shots, but check out this other bit of tech. So we partnered with the French Institute for Research in Computer Science and Automation, also known as Nvidia, these smart cats. They're world leaders in cinematography AI, and what they built for us is the director line system. So you know in movies there's like the 180-degree rule or the director line rule, and once you set up a scene, you can't cut across it, otherwise it's super confusing for the audience.
Right. Or in one shot, the player is running on the left, and on the other shot, he's running on the right.
Yeah, it's disorienting. So we fixed that, and we have that in there. So like, it's this cinematography 101, and it's not just the director line. We check for jump cuts, we preserve heading, and we check for screen space continuity of subject on screen size. So it's like Cinecast went to film school.
All right. So this is all cool stuff, but let's talk about how we can use this technology, because that's what I'm excited about.
So say you're on a dev team, and you've got to make cutscenes, or game trailers. Well, this gives you a huge head start. And if you're doing replays, you may know how hard replays are, right? Because the user has control. We don't know what's going to happen next. So Cinecast is designed to handle these kinds of problems.
And for esports, I don't know if you know, guys, but gaming is so big, it has surpassed the movie industry in revenues and the sports industry in viewership.
Which is crazy.
It is crazy. And Cinecast allows dev team to have a spectator mode right from the start. It's actually something that I didn't even think was possible before meeting your team. In esports again, Battle Royale modes are super popular, and I think Cinecast can be a game changer for it. So many teams are trying to get into this space, and a spectator camera and a Battle Royale mode is super hard to understand. Yep. When you have 128 players playing at the same time on the same server, you can miss a lot of the action, and it can be really confusing and chaotic.
Yep.
Well, Cinecast opens that door to fixing that exact problem. It's mind-blowing.
And we know what you saw wasn't perfect, but it's game on. And we're building this stuff, and we're not done. And we want to work with you. So if you're interested in this, let's connect. Let's make something great. Thank you.
Thank you, guys.
Please welcome Peter Andreasen.
I've been making games for more than 15 years. But every time you switch engine or technology, it's almost like starting anew again. So when I began to start using Unity, I really wished I had a large game project that I could open and study to really figure out how everything fit together in this new engine. And when I joined Unity, I got an amazing opportunity to build exactly that project. So we assembled a team of game developers who had all made many games before. And then I asked each of them, what would you like to see in an example project? What would be most useful for your profession to see? And today, we're ready to show you what we built. We call it the FPS sample, and it's a project you can open right in the editor because we wanted to show you not just what you can do, but how you can go about do it. So let's take a look at the footage. It's looking pretty nice, right? So, we are game developers, many of us, and if you are like me, you can't take a look at a game frame like this without starting to think, how was it all made? So how did they do this thing? Maybe you look at the hands and say, did they use IK to make it grip the weapon? And because in this project, you have the full source code available, you can actually just go in and find the answer yourself. Here's the file name you need to check out. And yes, it's a bit of a giveaway with the name. So yes, there is IK on the hands. Or what about this very nice-looking plant over there? Take a look at the red flower. It almost looks tasty, I think, actually. Maybe it's poisonous, but I'm very interested in figuring out how is it made to look like that. And in this project, you also have all the assets. So you can just go, click on this material, and in the inspector, you can see how everything is set up. Every single frame in a game contains hundreds of questions. You probably have some yourself when you see a game like this. Questions about UI, about rendering, about physics or game control, sound, well, anything actually that goes into a game. But there are two big themes from our project that I would like to talk about today. It's netcode for shooter games, and it's stylized content for our new HD render pipeline. So many of you are playing games online, I'm sure, and you can tell all about the problems there is with cheating and with network lag when you're making those games. And to solve those problems for a fast-paced shooter game, you need a couple of things. You need an authoritative standalone server, you need client-side prediction, and you need some sort of lag compensation. But even if you've solved those problems, go take a meeting with your boss, and she will be able to tell you about the cost of hosting this game. And then suddenly you also have to solve the problem of network compression and finding a way to give your servers a very small footprint. We believe FPS sample is a really great starting point if you're going to tackle any of these problems. And speaking more about netcode, our project is using the brand new transport layer that we are just shipping in preview now from Unity. And that's a general principle. In the FPS sample, we try many of Unity's newest features, almost as they are made, actually. So how to put this? Sometimes we have the opportunity to break a few things so you don't have to. Likewise, in the FPS sample, we are demonstrating a use of the new HD render pipeline. Achieving your particular goals, artistic goals for your game with a new render technology can be difficult. But here's a project where you can open up and see how everything is made. Maybe pull a few sliders, find something that looks like what you're trying to achieve. And this way you can learn how to work with layered materials, with HDR lights, post-processing stacks, and the different light modes. Our technical art director actually says it's like we are making a manual without words. And I think that's a great description of our project. But I don't just want to talk to you about the big fancy features, because this project also contains all the little details. So this is the things that every team has to solve when they are building a game, but that we usually do not talk so much about in demos and in tutorials. Today we're going to make an exception, though, and I will show you a few of the unsung tools, maybe, of the FPS sample. So in the corner here, I have a tool that I can use to launch our game in different multiplayer configurations. So here I'm spinning up a headless server, this one, and two clients are now trying to connect to it. One is there, and another one is here. And then I just want to show you some in-game tools as well we have here. Just stuff like being able to maybe shift to the next character, or show some useful stats to check out how the game is performing. Back in the editor, let's zoom right past this tasty flower here and take a look at this pipe. I want to show you one of the tools that the artists are using here. And this is the ability to override just a single parameter or a few parameters from a material using material property blocks so without actually generating new materials. So I will do something very artistic here and change this to a nicer tint, like this. So these are not rocket science tools, but I mention them because I want to tell you that everything that we use to make this project still is in the project for you to take a look at. And today, we're releasing the first version of the FPS sample. It runs on the latest beta of Unity 2018.3, and it's actually going to be a living project. We will continue to optimize it and to improve it and to adapt new cool features as they come out in Unity. The FPS sample today has one fully populated level, 2 super cool characters, and, well, everything else that I've shown you here today. Thank you.
Please welcome Brandy House.
Games make it easier to form meaningful connections with others. Whether solving puzzles with friends or taking down a raid boss, we take on these challenges together, and we overcome them together. And with that, we form lasting bonds. I think this is why connected games are so successful. With Unity and Google Cloud, we want to bring connected games to everyone. And we're focused first on real-time multiplayer games, like the FPS, Escape from Tarkov, or Crowfall, an MMO, or the ever-quirky Ultimate Chicken Horse. You've told us these are the kinds of games you most want to make, but it's just too hard to succeed. And as a result, there are incredible ideas never brought to life. We understand you pour thousands of hours into a game, and when you see negative reviews, it's heartbreaking. And then to realize the underlying tech failed you somehow makes it even worse. So we're tackling the 2 hardest problems first, performance and scale. As many of you have already heard, Unity is creating new engine features with performance at its core, and that includes networking. The new transport layer will support multi-threading with the job system and can benefit from burst compiler performance improvements. And moving forward, new features will come as full source packages so you can debug and optimize for your game. And not only are we providing transparency, but also modularity. As we showed in the FPS sample, you can build components like client-side prediction, interpolation, and delta compression, just like you see in today's fast-paced games. And while some creators want to create a tight experience between a few players, others want to connect hundreds and more, which requires both performant code and a scalable network topology. And while a peer-to-peer network seems straightforward initially, as you add more and more players to the network, it becomes increasingly unstable, and eventually it will fall apart. So instead, we're providing a dedicated server model that centralizes network traffic and provides your players a more consistent and secure experience. And to be truly successful, you need to be able to scale this model to all your players. So with Unity and Google Cloud, you can deliver high performance to players around the world with more than 100 physical server locations, a vast optical fiber network, and more. We're just at the beginning of this journey. And I'm grateful that, as Unity, we have the opportunity to solve these challenges across the entire stack. Everything you need to succeed. And to ensure all your incredible ideas can be brought to life, we need you building alongside us every step of the way. So we're shipping everything we have today in alpha, from networking libraries to fully integrated game services and samples that tie it all together. We look forward to building the future of real-time multiplayer games with you. So sign up today to be among the first to build the future with us.
Please welcome Arissa Scott and Chad Foxglove.
Earlier this year, we opened up the black box of rendering by introducing new graphics architecture, scriptable render pipeline, which allows you to create your own custom render pipeline. Or you can use one of the two we offer you out of the box. Lightweight, which is lean, performant, and scales across all Unity platforms. Or HD, which offers high-fidelity visuals for console and PC. On this foundation, we've built tools for creators like Shader Graph, which allows you to create shaders with no code required. Today, we want to introduce to you another tool, the Visual Effect Graph, which allows you to create stunning visual effects. Let's take a look.
So I'm going to share with you a preview demo that our team is working on to show off all the cool new features of the new visual effects tool. And this is running live on consumer hardware in the latest beta.
Hello, Baker. Can you hear me? I hope you made it safely down there, and I hope you can hear me. I can't hear anything. The whole system's busted. There you are.
Security check in progress.
I see you in the monitor now. Good to see you well.
Access granted.
So with the new visual effect graph, you're able to create simple effects very easily, like this steam and these sparks here. And these are pretty standard. You've probably seen these in a lot of games. But with our new capabilities, you're able to easily build up to much more sophisticated pieces, like this holographic display.
Hurry up and get us to the landing site.
And the visual effect graph offers a lot of flexibility, which we needed for this display. It's doing some really crazy stuff under the hood.
That's the one. There it is.
Like here, for each individual pin, there's behavior driving it that has a custom height field and a procedural wave function. So let's take a look at that graph.
For sure. So here's the new visual effect graph. So you can see, and you mentioned this is a pretty complex effect, and so there's a lot of math to go behind this. But the node graph makes it easy to organize your logic visually. And because it's a node-based system, it's easy to use and flexible. And so that empowers artists to create stunning effects quickly with an intuitive interface.
And one thing that's really nice about its visual organization is you can see that we have these building blocks here that walk you through every stage of the effect creation process, from spawn to initialize, update, down through to render. And if you want, you can connect in even more functionality.
Totally. So we provide a library of ready-made nodes that you can just easily drop into your graph for simple things. If you want to make something a little crazier like this hologram, we also provide an API for creating custom nodes. So you can extend our core functionality with your own ideas.
And with a bit of code, you can script it up so that you can connect effects directly into your gameplay. But if you don't want to dig into code, you don't have to.
Yeah, totally. You don't need to write code if you don't want to. So let's try to make a simple change here. We have this height field. We can easily change the look of that up. All we got to do is find the height field node here. And then we're able to just change the texture. And now we got a Unity logo.
Cool. It's nice. You can author effects that range from simple to complex.
Yeah, and it's super responsive too. You'll notice that all the changes I made happened in real time in the scene view. So there's no need to rebuild your project each time that you make a change.
And all these effects are stored inside visual effect assets. Each one contains a graph with the mesh, particles, and behavior you need for a standalone effect. And while building this tool, we were inspired by the leading tools for creating VFX in film, which you can see in the paradigm here.
Exactly. So it's integrated with tools that you already know and love in Unity, like Timeline. So we built this new system from the ground up, using the GPU to do all the heavy lifting. And as a result, that means that the new architecture can easily handle millions of particles.
The visual effect graph is available in preview for 2018.3 for HDRP, with lightweight support coming later. You can try it out right now, and we'd love to hear your feedback so we can make it even better. Thank you.
Please welcome Lydia White.
The world of games and entertainment has always shared a passion for storytelling and beautiful art. Two industries who influence each other, proving that the best of both worlds is maximizing potential for all. So at GDC this year, we launched our largest, most ambitious challenge to date. By partnering with Universal, Microsoft, and Intel, we were able to offer a once-in-a-lifetime opportunity. Over the course of 90 days, you shared with us your vision of PC games using iconic Universal brands. Finalists from all over the world, from a one-man shop in Australia to a team of a dozen in Switzerland, submitted their own playable prototypes, each with their own unique look and feel. From the unexpected charm of Turok: Escape from Lost Valley to the hardcore fight for survival in Battlestar Galactica: Deception, these final prototypes highlighted your best Unity development skills. Let's take a quick look. It is now my pleasure to introduce you to the grand prize winners of the Universal Game Dev Challenge. Gabanga with Voltron Cubes of Carrion.
Thank you.
Welcome. Congratulations.
Thank you.
Great. So what is it that you guys enjoyed the most about participating in this challenge?
It is really exciting to get to work with the famous Voltron universe. And we're proud to have contributed fun and deep gameplay that works well with the characters and their adventures in the Voltron storyline. It shows that creativity is a boost for all brave franchise owners, for the benefit of everyone. The fans, the players, the studios, and developers. We truly believe that this is the future.
Absolutely. I really love how you pulled in all of the elements from the show, and I especially love that you picked Pidge as one of the playable characters in your prototype. It's awesome. So do you have a message for the rest of the team back home?
We'd love to say a great thanks for our awesome team at home, Robin and Dominic for the gameplay ideas, Manu and Stepan for the beautiful designs and animations, Alex, Benjamin, Jonas, and Kevin for the programming magic, Valeria and Askan for playtesting hours of battles, and Ramona, Robert, and Matthias for quality story and the backing from management. We'd also like to thank the entire Swiss games industry. It might be small, but there is an incredible solidarity and team spirit across the community. We wouldn't be here tonight if it weren't for all of them.
Well, thank you for all your hard work.
Thank you.
Today, we're announcing another opportunity for creators to showcase their skills and creativity. The 2D Challenge. In the past year, we've shipped new 2D solutions like the tile mapper, the sprite shape, and character rigging tools, and now you can put your skills to the test. Check it out on Unity Connect.
Please welcome Kaki Navarre.
Hi, everyone. We're here to share with you an innovative collaboration between Unity and Disney Television Animation called Baymax Dreams. First, some backstory. My team at Disney is responsible for R&D focused on the television business, and we first became interested in real-time back in 2016. We realized that there might be a big opportunity here to transform the way linear television animation is created. When you're in production, normally there's a balancing act between cost, speed, and quality, meaning that if you increase one, like speed, another, like quality, can sometimes decrease. So there's a trade-off here. And this is a trade-off that we don't want to make. So we set out to change the paradigm. We wanted to discover whether real-time might enable us to produce animated content quicker and more cost-effectively, while maintaining the same high quality bar. And also, whether producing in real time from the onset would make it easier to create derivative experiences like games, AR, or VR down the line. This brings me to Baymax Streams, a series of 3 broadcast television quality shorts based on the Big Hero 6, the series TV show, which were created using a real-time production pipeline. Let me show you some excerpts from Baymax Streams. So how did we get here? When we realized the potential with Unity, we took the idea to Disney Television Animation, and they were immediately interested in testing the technology. Together with Unity, we assembled a production team made up of VR experts, game developers, and film professionals. As production got underway, we quickly began to see exciting results. We used Unity for everything from layout, camera, and editorial to lighting, VFX, color correct, and render, with the goal of consolidating as many disciplines as possible within the real-time engine environment. This workflow enabled our team to iterate quickly and immediately see creative results in context from the very start of production. We spent less time shuttling data between different applications. We saw synergistic benefits from having a multidisciplinary team all use the same content creation tool. As the team's knowledge of Unity expanded, productivity grew exponentially. But what really surprised us was when we began blocking out the story in Engine using real production assets. We were able to do this extremely early in the life of the production, before we even had a locked script. This ability to find the story in real 3D world space could hold exciting possibilities for the future of storytelling. The collaboration was mutually beneficial. We've received an extremely positive response to the creative quality bar achieved by Baymax Streams, both within Disney Television Animation and among viewers. We learned that we can, indeed, use game production tools to produce broadcast television quality shorts in Unity. And Unity has been incorporating updates and additions to their roadmap inspired by learnings from this production. Lastly, I wanted to let you know that Baymax Streams is now available to stream on both Disney Now and Disney Channel YouTube, so you can check out all 3 full episodes there. Thank you.
Please welcome Lucas Meyer and Mark Drosty.
Hi, everyone. We're going to show you what it feels like to work on a production like Baymax Streams in Unity in real time. I'm going to be the director, and Mark, you're going to do all the work.
Sounds about right.
I should get into management. I'm only half joking. Anyway, let's get back to it. Mark, when you work on broadcast television production like Baymax Streams, why is working in real time such a big deal?
Well, A, it's more fun. And B, we're used to working in siloed off departments, right? So everyone's work will come in one after another after the other. Whereas on Baymax Streams, we worked on everything in real time. So we had lighting, editorial, camera, animation, compositing, all available to us in one place.
All right, well, that sounds great, but let's take a look at what that really means in practice. If you get set behind the machine, what I would like to do is I want to take one of the shorts that Mark's team produced and take a slice of it and have some fun with it here on stage. This is the section we'll be playing with. We have our friendly Baymax here waiting on the train. I guess it's a trolley. He gets on the trolley with his jolly sheep friends, but little does he know, Gets blasted from the sky by this red laser. Trolley goes boink. All right. That's the clip we have. And we're going to see in about 5 minutes how drastically we can change this here. I was thinking to go for a little bit of to turn it into like a Halloween special, make it a bit more spooky. And Mark, the first thing I was hoping to do is instead of this red laser blasting the car from the sky, what I would like to do is like add an enormous monster that walks towards the trolley and sort of like steps on it instead. Go.
Okay. All right. So giant monster, giant monster, giant monster. I got a sheep.
Really?
Yeah, I have a giant sheep, which is scarier.
I don't
scarier?
know.
Hold on. I got
But
this.
the crowd seems to love it, so we'll roll with it for a little bit.
Right? Scary giant sheep, right, guys? Yeah?
Okay, looks like we're keeping the sheep. But can you make does it have an animation already? I need it to walk towards the trolley.
Sure. So I'll just pop into my timeline here, and right from my editorial suite, I can grab an animation, and I happen to have the perfect one, a nice shambling zombie walk, perfect for Halloween. Huh? What do you think?
Yeah, I think we can work with that. But it's hard to see from this shot. Can we just see it with the actual camera work?
Sure. So I'll just pop back into my game view, and we can actually check out what it looks like in edit. So I'll just play it for you from here.
All right, this is where they come under the bridge. This is where the laser was. Oh, okay, well, I guess that kind of works, but the monster sort of appears out of nowhere. So can you show me the camera shots that you have?
Sure.
And let's take a look at the first shot. Yeah, this is where they come under the bridge, and then like that second shot where they look up.
This one.
I don't think that works because we don't have this laser anymore. So let's get rid of this camera, and instead, I'd like to see a camera that sort of like looks at the monster as it's approaching so that when it steps on us, it doesn't give us a heart attack.
All right, sounds good to me. So I can we use Cinemachine on Baymax streams, and one of the great things about that is I don't have to go back to layout or anything. I can just drag my camera right in here. So you can see I have all my shot clips up here, dragged in a new camera, and voila, there we have the sheep. And the other great thing is that Cinemachine targets the character, so no matter where he goes in frame, he'll always be on screen.
Okay, so if I'd ask you to make it fall from the sky, that'd be no problem.
Well, I mean, that depends. You can ask me to make him fall from the sky?
Today, please.
Okay. All right. Well, asking you shall receive.
Everyone's waiting here, Mark.
I've got the animation also here in my timeline, and I'm just going to bring him up to the top. We'll just do like that.
Yeah, like from the sky, not from the second floor.
Okay. All right, here we go. Anything for you, boss, right up
All right, here we go, yeah.
Huh?
Okay, Leah, let's try that, but let's see it with the actual camera work again.
Okay. Just play it through. There we go.
Okay, yeah, that's getting there,
Yeah? It's feeling scary to me.
Although it seems like the whole audience is loving your sheep, I'm not sure if it really has this sort of scary, spooky feel yet. So
Well, they have taste.
that is true. Let's take this monster and let's turn it into like a zombie sheep. Let's give it like black wool, green face.
I can do that. So I'll just jump into the shader here. I'll change the base color of the wool. I'll drop it down to black.
Did you use like the regular Unity HDRP for this production?
Yep. And I'll just frame up on his face here, jump into Photoshop, and we'll make him green. Save that out. And what's great about this is that I don't have to go back to 4 different departments, wait a week to see it. Boom, there it is. Green face sheep right there.
All right. So it's getting closer, but it's still sort of playing back in this like bright blue sky, happy daytime setting. Can you turn this into more of like a nighttime?
Yeah, I can do that for you. So I'll just unload my lighting setup. Grab these guys here. All right.
Whoa.
Too dark?
Not really what we're going for.
I mean, I told you sheep could be scary, so. All right, I think I have a better idea. Let me just load this in. And boom, night setup.
All right, that's okay. Let's fix up a little bit in the color correction as well.
Okay.
Or can you show me a different shot, like the shot of the
trolley?
Yeah.
This one here.
Okay, let's fix it up a little bit with the post processing. with the color grading.
So I have access to all the tools that would make a compositor feel at home. And if I just check out my post-processing volume here, I can go a nice dirty slime green. Yeah?
Yeah, maybe not. Maybe a little bit more like a light purple.
Light purple, so like here, we're looking at here?
Yeah, a little bit less. It's still a kid show.
Oh my God, okay. Just, how's this? That feel?
Yeah, let's run with that.
Okay.
Let's run with that. Actually, I think that's about it for the 5 minutes we have here. Let's roll it from the top. Just
wait. I loaded up a couple extras. I didn't want to go through you because I thought maybe you wouldn't understand, but I have music and some zombie noises that no Halloween episode is complete without. So, without further ado, here's our Halloween special. And there we are.
Well done, well done.
Thank you.
High five.
I did make 3 of these.
So, what did you say?
I did make 3 of these.
Oh, yeah. All right, so here on stage, we were able to take this production, we changed the story, we added an enormous monster, made it fall from the sky, we adjusted the camera work for this new event. Then we changed the character of the cast. We changed the whole thing from a daytime setting to a nighttime setting, and we did color correction all here in the same tool.
Yeah, and I mean, that's a great example of what it was like day to day for us. The director would sit right behind me, and he'd ask for changes, you know, some as ludicrous as a giant zombie sheep. And I didn't cringe. What if wasn't?
The sheep was your idea. The sheep was your idea.
I know, and that's why it was good. And but I didn't cringe, you know, when he asked for that. It was just, okay, what if? Let's follow this and explore it. And that's how we arrived at better stories faster.
And now that you've actually used Unity to create a broadcast production like this, you do realize that you now have like all the assets for the production in a game engine.
Exactly.
Are you planning to take this anywhere?
Well, I mean, we could.
Actually.
Oh, hey, Kaki.
Hey, guys. So as we speak, Walt Disney Television is doing just that. We'll be launching a new game in Disney Now early next year. It's inspired by the Baymax Stream Shorts and reuses assets from our real-time production.
Oh, very cool. Give me a call when I can play it.
I will.
Thanks, everyone.
Thank you.
Please welcome Natalie Grant.
When it comes to the world of real-time filmmaking, there have been 2 areas that have seen some serious momentum this year. Animation, like short films and episodic series, and virtual production, which is using Unity on a movie set to shoot live actors in context with CG environments. And it really is because of creators like you who have led the charge in telling these incredible stories. Whether that's combining 2D animation and 3D art for a stylized short film like Sonder, or extending the narrative of your game world by creating a music video, like Take My Hand from the world of Golf Club Wasteland. Or even rendering out a 2D flat film from a VR experience, like Crow, the Legend. Unity is, for animation studios, the creative center of your pipeline that allows you to craft these narratives in a much more intuitive and flexible way than traditional workflows. Now, let's talk about virtual cinematography. MPC Film, a visual effects and film production studio, won a 2017 Academy Award for their work on Disney's The Jungle Book. In order to create this almost fully CG, photorealistic movie, it required virtual production. So the director, Jon Favreau, could visualize this beautiful world that he and his team had created while he was shooting his live actors. And this led MPC to create Genesis, an end-to-end virtual production platform built on Unity. Genesis combines the handheld camera work of traditional filmmaking with real-time technology. And that lets crews create and experiment and iterate on set together in real time. Another pioneer in real-time filmmaking is Digital Monarch Media. Now, they've got a suite of virtual production tools that allow for the simulation at runtime of manipulating lights and cameras and rigs and capture, you name it. And this team is led by Wes Potter and Habib Zagarpour. Both of them have a deep background in cinematics, in gaming as well as in film. They noticed early on that the immediacy of game technology could drastically improve the creative output of the movie-making experience. Habib went from a master's in fine arts to programming and went on to work on some awesome game franchises. And Habib has been nominated for Oscars and even won a BAFTA in visual effects for his work at Industrial Light and Magic. And both of them worked on Ready Player One and Blade Runner 2049, meaning they introduced directors like Spielberg and Villeneuve to the power of Unity. So it's no secret that both Unity and DMM are super passionate about the convergence of visual technologies in entertainment, and that we both care very deeply about the success of creators in film. So, on that note, let's get some Unity folks out here, because we have a special announcement for you guys.
So hi again. Now, earlier, I highlighted the idea that we have a commitment to leaving no developer behind. And this includes film studios, a group of creators known for leading the charge and telling incredible stories in new and captivating ways. And today, we're so proud to announce that we are merging or acquiring Digital Monarch Media. And I'd like to invite Wes up to the stage, the founder. And I'd also like to recognize Habib, John, Pete, Marina, stand up. The rest of the team. And you guys are awesome. Oh, you're coming up. Come on up.
Come on up.
Uh-oh.
I don't know if we have insurance
Workman's
for this.
comp.
Okay.
All right, here we are. All right, so Wes.
All right, man. Here we go. So my team here, oh, where are they? Come on. You guys can't hide back in Unity yet. Come on. Jeez, you got years to do that. So I and the team at Digital Monarch Media have been long proponents of Unity, as I'm sure many of you have. Today, we invite you to join us in a new narrative between our companies. A narrative where cinematographers and storytellers are empowered to craft their worlds and voice their ideas atop the world's most powerful and prolific platform. They do this while still employing the tools they trust and the skills that define their craft. Now, over the years, graphic fidelity it's skyrocketed. Unfortunately, many creators have become technologically severed from their creations through undue process. This incurs not only a high cost, but it blinds vision. Our team, alongside Unity, have built a suite of virtual film tools to bridge this gap. The gap between art and artist, DP and camera, and actor and stage. This is virtual cinematography. We believe that in iteration, in focus, awareness, and ever so often serendipity, movies are the doorways to the halls of magic. Unity is more than a platform. Unity is actually much more than a platform. It allows filmmakers to become dynamic and flexible, immediate and direct. With Unity, this does not require an army of engineers. It just requires the armaments of imagination. We look forward to this journey alongside the directors and artists and story makers, but most of all, you. Thank you.
Guys, we're off.
Please welcome Joachim Monti and Martin Kimmel.
Thank you. So for the last couple of Unites, I've been showing you different demos, all surrounding our new data-oriented design technology stack. And we have built a solid foundation for writing high-performance code in Unity. And now we're beginning to build higher-level features on top of it. And we're doing that with real-world production needs to ensure that everything works and performs well out of the box. So what did we want to achieve this time around? We wanted to stream large amounts of content at a solid 60 frames per second. We wanted to go completely nuts with the amount of unique things we can have on screen at the same time. And we had to make sure that we have efficient tools to actually create a large world with a tiny art team of just 2 artists in a couple of weeks. So before we get into the details, let's have Martin have a play.
So hi. So the world we're about to dive into is inspired by the walled city of Kowloon. We've added a bunch of sci-fi elements to it, but let's dive in there.
Controller not working?
Nope. It's even taped down.
Fantastic. Actually, let's just quit and restart. We're doing it live. It's coming right up. No worries. There you go. Perfect. So look at all those cars. There are 5,000 separate AI agents, all flying on these traffic lanes, avoiding each other and the player. And the entity component system is uniquely suited for streaming huge amounts of scene elements. Each building that you see here is made out of 30 to 200,000 separate entities. And all of that is streaming and then activating all in one frame while still having a 60 frames per second. And then, for good measure, we put in 100,000 audio sources. Each neon sign, every vent, every flying car has an audio source on it, and that creates that dynamic audioscape. So we built this project. Oh, yeah. Yeah, it's pretty cool. So we built this project on our in-preview data-oriented design technology and a bunch of optimizations that we did to Unity to make this come together that we're bringing into Unity 2019.1. So we have the C# job system. With that, we can run all of this code on multiple cores, and we can do that easily, and we can do it safely. We have the entity component system, making it easy to lay out all your data for the best memory access performance. And the Burst compiler gives incredible speedups by generating efficient machine code for the target platform specifically for C# jobs. And then we also integrated the entity component system with the HDRP and LWRP render pipelines. And we built a scalable renderer for entities. So Martin, how many renderers did you actually end up putting into that scene?
Well, me and Janus just kept piling stuff in there, right? But I think at the end we're around 4.5 million mesh renderers.
Just a couple, here and there, sprinkle them around. So what we did is we have a culling system that is written in C# using Burst, and we perform hierarchical culling and hierarchical LODs. So when a building is outside the view, there's no reason why we should cull those 200,000 separate renderers. We can just reject them very, very, very quickly. And then we did some intense optimization work on our rendering inner loops to make sure that everything is performing beautifully. So this level of performance and scalability allows us to completely change how we author content. And it also means that we can load and edit these scenes really efficiently in the editor. So Martin, show us a little bit about how you actually assemble this content.
Yeah, so when a few months ago, which is actually when we started building this, our environment artist Janus and me were approached with this project, which sounded a bit crazy. So how would we build a streaming world by October? To us, this conjured up images of, massive streaming worlds and huge openscapes. But with very little time, what could we really do in that time space? So let me dive a little bit into how we built it. So I'm going to open up the scene. And the thing you'll notice is that the LOD system that Joe was just mentioning, you're seeing it in action now. So the first thing it loads in is the HDAR. So very quickly we're in the scene, and it's streaming in hierarchically stuff as it encounters it down the line. So it doesn't take long to open a world of this scale and size. And once we're in there, the ECS representation of every mesh renderer actually makes this pretty damn interactive. So we're able to fly in edit mode around our city, vehicles spawning on paths, buildings being streamed. So I'm going to head over here, home in on this particular building, which I've practically prepared at the top of my hierarchy. And at this level, we just see a single object, because we're still in ECS representation, but it's a subscene, and it's part of the streaming scene setup. And I'll open up that for editing, and we'll see that a whole game object appeared underneath it. So these are nested prefabs, right? The entire building is a single prefab. But I can go in on this level and, move stuff about. Maybe I would want to, tunnel through the building or something like that, or add a bespoke game location. This would be the right layer of inheritance to do that in nested prefabs. Or I could, go deeper into the building itself. And that would allow me to make changes to all buildings of this type. In here, I distribute things like neon lights that are repetitive throughout the scene, but don't repeat that well. So they're good to place on a building level. If I go deeper yet, I can go into a corner tile piece, and this is where the satellite dishes, the air conditioners, the dirty laundry, etc. is distributed. And I can go to a leaf prefab node, which is actually a prefab variant, where I have the air condition unit. So this is the level of detail on every prop that you see of the 4.5 million mesh renderers. They are actually fully detailed game assets with every blade modeled, etc. And then here we have our ECS sound emitter source as well. So literally every single air conditioner in the entire level is playing its noise. We actually don't have any ambient sound loops at all. It is just all the noises coming together. So the benefits of nesting prefabs were quite immediate on this. We could easily manage our base assets with the FBX inheritance given by prefab variants, and reduce permutation immensely by having deeply nested hierarchies to form up each city block. So buildings shaped out of tiles, dressed with detailed props. And this made it really easy for us to go and make changes and have them propagate globally. Without this new workflow and the performance provided by ECS, it wouldn't have been possible to maintain this level of detail and polish the city to this amount in a few months. So yeah, with these new features, everyone from audio designers to level designers and artists can easily work in parallel and inject their changes anywhere in the hierarchy they wish without obstructing each other. So yeah, to recap, we have a scene with 4.5 million mesh renderers, 100K individual audio sources, 5K dynamic vehicle agents, and 200K unique individual objects per building, streaming at a hitch-free 60 FPS. So Joe, you're getting something ready?
Yeah, there's one more thing I want to show you. So look at this. So our friends at Nordios and the mobile team at Unity worked together to make this demo actually run on a mobile phone. And a lot of you are making games for mobile. And the entity component system and the burst compiler is a great solution for reducing battery consumption and getting better performance on any hardware. And better performance results in you reaching more users. And that is useful if you're making anywhere from a small 2D game and you just want to reach the lowest end devices, all the way to making a large open world like this. And the good thing is, all of this, including all the assets that we used in this demo, is going to be available in 2019. So thank you.
All right. You know, it just occurred to me, if that runs on mobile, it should run in virtual reality, right? So that's what we're going to do next.
I did model the cockpit of the car, so we're ready.
Yes. OK, it feels a little lonely out here. Can I get some friends on stage with me? I don't want to be alone right now. I want to be here with you. OK. We want to say thank you. Thank you so much for being here tonight and for your creativity that inspires us every day in all the work that we do. It has been an incredible year. There have been so many great projects, so many great experiences, and so much more to come. And we look forward to cheersing you all tomorrow night at the reception. Thank you very much.
Oh, it's that line.
Was that right?
I can hear myself.
Hi.
Oh my goodness.
We're back. How was that, Liz?
That was incredible. Like, I knew that Mega City demo was coming, but it still completely blew me away.
Yeah, I know, right?
It was just insane.
I was a little bit worried. We had a little bit of a technical difficulty, but we got there in the end.
It was so worth it, though, and it runs on mobile, which is super exciting.
Yeah, I was pretty excited about that reveal. I knew that was coming. So there's a whole bunch of takeaways from this, guys. So we've got a whole bunch of stuff for you to check out.
Yep.
We've got the ECS stuff coming next year, but we've also got stuff that you can get right now. So we've got the ECS stuff streamed live tomorrow.
Yep.
So check that out on the live stream. You can also watch it on YouTube after the fact. There's a download for Cinecast.
So Cinecast, and then we've got the FPS sample game, which again looked awesome.
Yeah, and of course the visual effect graph.
Yep.
So you can see everything that we showed in that demo. You can do with the visual effect graph. Download 2018.3 beta, so unity.com/beta, or download the Unity Hub and go to installs and then choose beta, and you'll be able to install that. Go to the package manager, and then you'll find a lot of the features that we listed here today. There's also blog posts that are covering all of this stuff that you've just seen in the keynote.
And also, don't forget to pop along to Connect.com and sign up for the 2D competition, which looks awesome. And congratulations again to the winners of the Universal Challenge.
I think we've been eating too much popcorn.
I'm so high on sugar. And that ECS demo.
Yeah.
Honestly, I know I keep going on about it, but the Mega City demo is insane.
So we're high on popcorn, and we hope that you've been high on the Unity Los Angeles 2018 keynote. We will see you at GDC.
Hopefully very much so, yes.
Yeah, very soon. And thank you for joining us on the stream.
Thank you so much. Enjoy it.
We're going to join everybody.
Bye.
Okay.